everyone, welcome back to my channel. Today we're going to solve the linked list cycle. So basically we will detect whether there is a cycle in the linked list. So we're given a head, the head of a linked list, determining if the linked list has a cycle in it. The definition of the cycle is that if there is a node in the list that can be reached again by continuously following the next pointer. So like in this example, if there is no cycle, it should be from the 3 going right, going right, going right, keep going. And it should be no if there is no cycle. But if there is a cycle in the list, when we reach the -4, we will pointer back to the 2 and going right, and going back to the 2. So it would be just like a loop in the list. And we will never get to the no. What we going to do is to detect if there is a cycle in the linked list. The most intuitive solution of this problem is that we can create a hash table or hash set to record every element that we have visited. So when we reaches the -4 and point back to the 2, we will know that the 2 has been visited, and we will detect it that there is cycle in the linked list. However, if we use hash set, the time complexity is just like to visit every element in the linked list, so that would be O(n). However, because we use extra data structure, we will have some extra space complexity. So the space complexity will also be O(n), because we need to, add every node into the hash set. The size of the hash set is the length of the linked list. Is there any way to have constant space to solve this problem? So we will use the technique called slower pointer and faster pointer. So basically we will use 2 pointers to solve this problem. One of them is slower and another is faster. So the slower means in every step, we will shift the pointer just 1 step. And for the faster pointer, we will shift the pointer twice. Okay, we can see this in the illustration. So at the beginning, 2 pointers both point to the first node. In next step, the slower pointer will shift just 1 time to the node 2. But for the faster pointer, it will go twice to the 0. Same thing in the next step, the slower will move to 0, and the faster pointer will move 2 nodes, 1 to the -4 and to the 2. Then slower pointer will move to the -4, and the faster pointer will move twice to -4, and they will meet at the -4. If they meet each other, we will know that we have a cycle in the linked list. So if there is no cycle, means that at the -4, it will point to no. So in this way, we will use another color, use green. So in this way, the first step will be the same. The slower will point to 2 and faster will point to 0. And for next iteration, the slower will move to 0 and the faster will move twice to the no. That's how we know that we have no cycle in the linked list, because we have a pointer points to the no. So basically, the time complexity will be O(n), but why? So imagine we have a loop. The letter S represents the slower pointer and the letter F represents the faster pointer. Say they are not at the same position at the initial settings, and there is a distance between them. They will, move clockwise. So the speed of the faster pointer is 2 and the speed of a slower pointer is 1. Why they will eventually meet? Because the faster pointer moves faster than the slower pointer. So basically the faster pointer will catch up the slower pointer. So in step 1, say the distance between them initially is 10, and for the first step, the distance between them will be 9, because the initial one was 10 and the slower pointer moved 1 step and the faster pointer moved 2 steps. So the distance between them will be 9. So basically, in every step, the distance between these 2 pointers will be reduced by 1. So after like 10 steps, the distance between them will be 0 and they will meet. So why the time complexity is O(n)? Because we set the distance in this case for 10, right? So what's the maximum distance between them in the initial position? It's the whole loop, right? So what does it mean by whole loop? It's just like the whole linked list. Imagine that the -4 will point to the 3. So that's the maximum distance between these 2 pointers. So that's why the time complexity will be O(n). If you can understand the slower and the faster pointer mechanism in the drawing, it's pretty easy to implement it in the code. So basically we will have 2 pointers, the slower and the faster. So at the beginning, we will just point them to head. So remember how well we know that we reaches the end or detect there is a cycle in the linked list if the faster points to null or the 2 pointer meet each other, right? The reason why I write a faster dot next here is because the faster pointer needs to move twice in one step. So we need to ensure that the next node of the faster is not null. If it's null, we will know that there is no cycle in the linked list. So if we did nothing in the while loop, we'll know that there is no cycle in the linked list. So for every step in the while loop, we will just move the slower pointer to the next one, and the faster pointer will move twice in one step. How will we know there is a cycle? Yes, if the slower meets the faster pointer, we will know that there is a cycle in the linked list. So it's pretty easy, and we will see if it's correct. Okay, so that's how we solve this problem.